150 years after the publication of Darwin's revolutionary book, modern genetics has confirmed its fundamental truth. All life is related. And it enables us to construct with confidence the complex tree that represents the history of life. It began in the sea, some 3,000 million years ago. Complex chemical molecules began to clump together to form microscopic blobs, cells. These were the seeds from which the tree of life developed. They were able to split, replicating themselves as bacteria do. And as time passed, they diversified into different groups. Some remained attached to one another so that they formed chains. We know them today as algae. Others formed hollow balls which collapsed upon themselves, creating a body with an internal cavity. They were the first multi-celled organisms. Sponges are their direct descendants. As more variations appeared, the tree of life grew and became more diverse. Some organisms became more mobile and developed a mouth that opened into a gut. Others had bodies stiffened by an internal rod. They, understandably, developed sense organs around their front end. A related group had bodies that were divided into segments with little projections on either side that helped them to move around on the sea floor. Some of these segmented creatures developed hard protective skins which gave their bodies some rigidity. So now the seas were filled with a great variety of animals. And then around 450 million years ago, some of these armored creatures crawled up out of the water and ventured onto land. And here, the tree of life branched into a multitude of different species that exploited this new environment in all kinds of ways. One group of them developed elongated flaps on their backs, which over many generations eventually developed into wings. The insects had arrived. Life moved into the air and diversified into myriad forms. Meanwhile, back in the seas, those creatures with the stiffening rod in their bodies had strengthened it by encasing it in bone. A skull developed with a hinged jaw that could grab and hold on to prey. They grew bigger and developed fins equipped with muscles that enabled them to swim with speed and power. So fish now dominated the waters of the world. One group of them developed the ability to gulp air from the water surface. Their fleshy fins became weight-supporting legs, and 375 million years ago, a few of these backbone creatures followed the insects onto the land. They were amphibians with wet skins, and they had to return to water to lay their eggs. But some of their descendants evolved dry, scaly skins and broke their link with water by laying eggs with watertight shells. These creatures, the reptiles, were the ancestors of today's tortoises, snakes, lizards, and crocodiles. And of course, they included the group that, back then, came to dominate the land, the dinosaurs. But 65 million years ago, a great disaster overtook the Earth. Whatever its cause, a great proportion of animals were exterminated. All the dinosaurs disappeared except for one branch, whose scales had become modified into feathers. They were the birds. While they spread through the skies, a small, seemingly insignificant group of survivors began to increase in numbers on the ground beneath. These creatures differed from their competitors in that their bodies were warm and insulated with coats of fur. They were the first mammals. With much of the land left vacant after the Great Catastrophe, they now had their chance. Their warm, insulated bodies enabled them to be active at all times, at night as well as during the day, and in all places, from the Arctic to the tropics, in water as well as on land, on grassy plains and up in the trees. Today, we and the rest of the mammals share the world with the descendants of those other great animal groups that have evolved on this planet, with birds, with reptiles, with insects and with fish, and even with those simplest of all living organisms that first appeared over 3,000 million years ago, with bacteria.